So continuing June 2007, Core 4, question 7, this is part C then. We've just discovered we've got this point here where they meet. Now these two lines, this is line 1 here, this is line 2. We know that they meet at 90 degrees because we found that they were perpendicular earlier, and we've just decided that this point here is 2, 12 and minus 7. We've got a point here A, there's this point here, and we've got another point over here B that's the same distance. And we're being asked to find out the distance from A to B. Well, my thought here was, first of all, if we find out what A to P is going to be, we've got to go from minus 4, 0, 11, and that's the point A, and the point P we worked out earlier is 2, 12, minus 7. Well, what is this A to P going to be? A to P is going to be, what's that, 6. From 0 to 12 is 12. And from 11 to minus 7, well, that's minus 18. I could work out how far that was. I could work out how far that was just by using my Pythagoras. 6 squared and 12 squared and minus 18 squared. And obviously it's going to take a bit of tapping there, but that works out to be the square root of 504. We know that. So if this distance here is the square root of 504, then that distance there is going to be the square root of 504 as well. So we can use another Pythagoras to say that, well, that's 504 plus 504 is going to be equal to AB squared. And so AB is going to be the square root of 1008. And that turns out to be 12 root 7. How do we do that? Well, we think about drawing a picture. We think about spending 4 minutes on it, but no more than that. If you haven't got a picture and don't see how to do it, they can eat up time. If you started trying to work out what the coordinates of B were, it takes a very long time to try and work that out. Mark scheme for all of it and say, look how quickly they just go for it there.